All right, let's share that. And hopefully that's good.
Yes, looks great.
Excellent. Right, let's just get started. Yeah, so normally I'd say good evening, everyone, but I can't make assumptions about time zone. So good day, everyone, wherever you are in the world today. It's early evening here in San Diego, where I am. Yeah, so today we're going to look at using the Redis, we'll call it a data structure server. You might call it a database, which is an extremely popular open source project. And we're going to look at using it for something it's not normally used for. It's quite often used for a cache, but it can also be used as a in-memory data store, and it has different data types, and we'll see how those work. We're going to do a little bit of looking at some Python code. We have an application that has a complete front end that's written with the Bulma framework, and that's not a focus of this, but all of the source code is available, and you can look at that and tear it apart and see how it works. The premise of this session is we're going to build a prize draw online application, or we're going to look at aspects of how you would use Redis to do a prize draw online application, which means we're actually going to give away some prizes. So if you have a GitHub account and you're interested in winning a Redis University t-shirt, then we'll be giving some of those away. And if you win, I will genuinely mail you one. We have a choice of sizes, and we have all the sizes in both men and women's styles. So to start off with, what is Redis? You may or may not have heard of it, or you may have like tangentially worked with it, or been involved in a project that uses it somewhere deeper in the project. In short, Redis is an in-memory data store. So this means that everything that you put into a Redis instance, so all of your data that you put in there to get back later, when you do those reads and recover that data back to your application, it's always going to come out of memory. It's not going to come from disk or cache or somewhere like that. It's going to come from main memory on the server. This means it's very, very, very fast. You can also persist that data to a hard drive, SSD. There's a couple of ways you can do that. So Redis can also be durable. This is like a common misconception. People believe that Redis is extremely fast for reads, but extremely dangerous because everything lives in memory. You can absolutely write things to SSD or drive. You can cluster the database, and if bad things happen and something falls over, it can recover from that. What does Redis mean? It stands for Remote Dictionary Server, and we'll look at what that kind of means in a minute. But it's very different from a normal SQL database that you might have seen before. So very quickly, there's two sorts of Redis. There's open source Redis that you can download, get the source for, build it, install it, do anything you like with it. That's available in several cloud solutions as well, including one from Redis Labs, the company that makes a commercial version of Redis, which is essentially extremely scalable. We provide it in the cloud and manage uptime and all of that stuff. We're going to focus entirely on open source today. So everything that we look at can be done with the open source version of the database that you don't have to pay any money for. And we're going to look at it hosted in the cloud, but it could be hosted anywhere. So what makes Redis different from a lot of databases that you might have seen before? So if you're used to working with, say, Postgres or Oracle or MySQL, you'll be used to the relational model whereby you create tables, and tables have schemas. They have fields in them, and each of those fields has a data type. So, you know, a date, a timestamp might be a date type, and a name might be a string, and some other fields like age might be an integer. And then they're organized into tables, and you use SQL. So you might be used to writing statements like select star from users to get all of the users back from the table. You may also have seen databases such as MongoDB, where you store essentially JSON documents, or BSON documents as they call them, but equivalent. Redis falls into a class of databases called key value stores. So other ones in this class might include, for example, Firebase. What this means is everything that you access in Redis is at a key. So instead of a table containing many, many records, a key would contain essentially one thing. So instead of a users table containing a record for Simon, you might have a key that we might call, say, users:\Simon, and that contains a string containing Simon. One of the interesting things with Redis is it has a whole bunch of different data types that do different things. So again, in a relational database, most of the data types do roughly the same thing. You can update them, select them, delete them, and so on. In Redis, we have basic strings where you can do that. We have hashes, which look kind of like objects. So the field value pairs stored at a key. So you might store a user profile about me in a hash, and one of the fields might be first name and value Simon, and then another field might be last name, value Prickett, and so on. Redis also has these more complicated data types. So a list, for example, models a double linked list. So we could use that for managing a queue of jobs, or anything that we want to use a list for. We can build a stack data structure out of it as well. We are going to look at today the ones that have the red heart by them. So we're going to look at some string values, we're going to look at some hashes, and we're going to look at sets, which model a mathematical set. But before we do that, we'll just switch to actual Redis instance and try this out. So the way that we deal with Redis is we connect to an instance, and then with a normal database, you might type, select star from users or whatever, write your SQL queries, or with Mongo, there's an enterprise tool that you can connect and write queries that will return JSON. So with Redis, we're using a tool here called Redis Insight. This is completely free. It's connected to my Redis instance, and I can do different things with it. So at the most basic level, I can send commands into Redis. So if I know what commands each data structure supports, I can build something and we can do something with it. So very simply, if I wanted to set a string value, I could say set my name to Simon, and hit return. So we've sent that command into Redis. Redis has come back with OK, and we now have a key called my name that has a value Simon, and we can check that out by doing get my name Simon. So, get my name, and it returns Simon. So what we've done there is just stored something in the key space, and it's a string. We can basically set and get it. We can't do a heck of a lot extra with it because it's a very basic data type. One of the other things that we can do with Redis that you might commonly have seen is we can expire keys. So after a set amount of time, we can say just automatically delete that. So if we say expire my name 20, then in 20 seconds, my name as a key will be deleted from the database. So right now we can do get my name, and we get Simon back. And if we give it 20 seconds, then what will happen is Redis will automatically delete that. We can also see how long is left on it. We got 2 seconds, and now if I do get my name, you see we get nil back. So that's been deleted from the database. What's the use of that? The primary use of this is what you've possibly mostly seen Redis used for if you are familiar with it, which is caching. So imagine we were doing some operation that involved maybe some other database or some other backend system or a lot of math or something. And that operation took a lot of time, and we wanted to save the result of it for when it's needed again. So we would then be able to get it very, very quickly out of Redis rather than recalculating it back on an origin server. So Redis can act as a cache and help applications scale by basically storing pre-computed cacheable results. And then if we know how long those are valid for, so like if it was a stock price, we might have it valid for like 3 seconds or something. But the amount of hits that we get on our stock price server might be so big that handing all of those off to Redis, where the data is read from memory, may mean that we save a lot of compute power on our backend server. We can use a smaller backend server, we can scale better, we can handle traffic peaks. So if something big happens with the Microsoft stock. The fact that we are caching it means that the backend server that's getting the real current value of the Microsoft stock will still get the same amount of traffic, because every now and then Redis, something will go and get the new version from the backend, store it in Redis. Everything else in the front end will get it from Redis for the next 3 seconds, and then a new version will appear when it's hit the origin again. So Redis is quite often used as a cache. Some of the other data structures we're going to look at today include sets, so mathematical sets. So what a set's good for is basically storing a group of things with no duplicates in it. So if I were to have like a really basic social network or something and I had friends, we could do something like add friends Simon, so friends of me, and I could say friends include Gillian, Louisa, Sue, David, Rob. So Redis then says 5. I have 5 friends that we added to a set. And I can then ask it questions like, do S's member, friends, Simon, Bob. Is Bob my friend? It says no, 0, he's not. But if I ask it, is Louisa my friend, we get a 1. Yes, she is. So we can use this for all sorts of things where we want to track membership of things, and also for deduplication. So if I'm already friends with David and say on my social network, David requests to be my friend again for some reason, then I can do add friends, Simon, David. And now we get 0. Nothing was added because David was already my friend, so nothing's changed. So there's like no danger in re-adding him multiple times. He's not going to be duplicated in my set of friends. So the other thing we can do with this is we can do mathematical set operations, which is kind of unusual for a database. So if I do another one, so I do add friends Louisa and put Julian and Mishi. Then Louisa has 2 friends. I have this other number of friends. And we can ask Redis to do what's called a set intersection. So find all of the friends who are in my set and in her set and tell me who they are. So if we do into friends Simon, friends Louisa, we have a common friend, Gillian. So you can use sets and obviously Redis for this sort of thing. Quite often when you're modeling this sort of data, you would use a graph database and a Cypher query language. So you'd use GraphQL. That's kind of like a whole other talk, but Redis also does that. But one of the simple ways you can do this stuff is with sets. So the other thing that's going on here that's kind of like not immediately obvious is, so back here, I added some friends to a key called friends:Simon. And at no point did I create that key explicitly or say that key is going to be a set. So one of the Redis like core beliefs, if you like, is keep it simple. So there is no explicit creation step for a lot of these things. If I want to create a set, I just do sadd. I don't need to somehow like provision a set beforehand or say how big it's likely to be. I can just create one and start putting things in it. Similarly, we talked about lists earlier, so I could create a list of things to do, for example. So if I do list push, jobs, mow the lawn. So we've now got a list that creates one job, that has one job called mow the lawn. And that was created by that list push command. I was like, no, list create. So if I push some more jobs, let's have like bath the dog and more stuff. So I can push multiple things in one go. Now I have 3 things in my list. So let's have a look at those. I can say list range, give me all of the jobs. And now I've got 3 jobs in my queue or in my list. I can use this like a queue as well. So I can basically say, I want to do the next job. What's the next job I should do? like I say, lpop jobs, which pops a job off the list. So that tells me now that I need to wash the car. And if we go back and say what jobs are on the list, wash the car has been taken off the list. It's been assigned to me to do. So you can build queues with this, which is kind of good for building things where microservices talk to each other, or if you're just building an application that has like a list or shopping list or queue or stack like functionality. So that's the sort of basic low-level version of dealing with Redis. We basically type commands. This tool also allows us to view the database more visually. So I can click around here. And what we're looking at here is what keys exist. So instead of looking at tables in a relational database, these are keys. So here I'm looking at Luisa's friends, and it knows it's a set. So it's rendered them out as a set. The jobs here is a list, and we have an order that they're in. I can also manipulate them. So I'm going to actually delete that entire list. And if we look at the friends here, I could basically say for some reason, we're not friends anymore. And now I've got one less friend. So there are commands for doing that. You can browse this as well. So let's go back to here. So basically everything is based around the keys. So you kind of need to know what the key for something is. So your application needs to be organized about that. So if you're storing users and they have a unique ID, you might have a key users : whatever the unique ID is, so that when somebody puts their ID into your application, you know how to form that key up and go get whatever the data structure is that's stored there. So we kind of covered most of this. There's all these different data types. They do radically different things. So unlike a SQL-based database where all of the things do roughly the same things, Redis, we have, as I said, strings, hashes, sets, lists. We also have a data structure called a sorted set that those of you who've worked in gaming might have used before. Basically, a sorted set stores unique users with a score against them and orders them, and it's ordered on insertion. So it's really fast to get the data out in a certain order. And that's quite often used for like a high score table or who's online since when type functionality in large applications. The product also contains things like a data stream, which is approximately the entirety of a product like Apache Kafka is a data type in Redis. So you can store real-time data and do time series stuff over it. And again, that's another whole talk. So as we saw, you interact with Redis using commands. So you would send commands into it, get results out. And you saw me typing commands into the Redis Insight tool there, which is great for playing around with it and learning some things. But obviously for real, you're going to want to write some sort of application with some sort of programming language and have that interact with Redis on your behalf. So brings us on to the application we're going to look at today. Basically, it's a prize draw application. So what we're going to look at is storing some really basic information about people that enter a prize draw based on their GitHub profile. We're using GitHub because it has public profiles, so you don't need any complicated code for APIs or anything to go get that information, and it's public. And GitHub users generally have pictures or some sort of avatar associated with them, so it makes for a nice front end. Then in the middle there, we have our application. So our application's acting as like a web server for the front end. In this case, it's a Python application that uses the Flask framework, which is a pretty popular framework that you'll find in a lot of different applications and in some serverless environments. It uses the Flask templating language Ginger, which is built into it. And then kind of the bit that we're going to focus on today is how it works with Redis and the Python code to basically receive information from the front end and send commands to Redis, deal with the results, and render them back out so that we get a web page. So what we're going to look at in the Redis side of the house is Redis is a server. So our application there in the middle is going to make network calls out to that. We're going to look at storing sets, strings, and hashes. We're going to look at some of the key expiry features that we looked at just now for caching. I'm going to look at something called pipelines, which is a way of, if you send lots of commands to a Redis server in one go, then you can save a lot of network round trips by pushing them all into like the same request and getting all the responses back in the same response, rather than like doing request to the server, wait for the response, request to the server, wait for the response. Given Redis is all about speed, where you can optimize things, you should. So what we quickly need to do is set up a price draw and see how that works. So we're not going to focus on the mechanics of the front end. The front end is in Bulma, which is a CSS framework that doesn't require any JavaScript. So it's pretty nice. What happens here is in the start state, we have a completely empty price draw application because there's no data in Redis yet that would indicate what the prizes are or who's entered. So we need to create some of that, and we'll look at that in a second. But first, I'm just going to do something here and get rid of all this example data. So that's completely wiped the Redis database. So if we now go back to here, there's nothing in here where we had that sample data before. So here's our front end. We don't have any prizes or any draw running at the minute, so we need to create one. So front end as an admin page. And what I'm going to do is add some prizes. So we'll have some t-shirts. They're all t-shirts because basically that's what we've got. So we'll look at why I'm giving them all numbers, or they're all differently named in a minute, but basically that's because we're going to be storing them in a set for some reasons we'll look at in a moment. So we need to have different names, otherwise we just end up with one prize because sets deduplicate. And then we're going to say we'll do this for like an hour. And what this is going to do is this is going to set the time to live on our prize draw. So after an hour, Redis is going to basically close the prize draw for us by expiring a key that the application looks at. And we'll see how that works in a second too. So if we do that, so we've now got a prize draw that's currently open. And we can take a look at what that actually means. So how did we get to, or what happened when I opened that price draw was I pressed a button and a form was submitted to our Python application, and it made a connection to Redis, and it sent Redis a bunch of commands to change some things in the database that we'll look at in a moment. So obviously I don't sit there and type those commands, the application's doing that. So how that happens is we use something called a Redis client, which is equivalent to a database driver for other database products you might have used. So we're using the what's called PyRedis, which is pretty common Python client. So we import that at line 1 there. We just say we want to use it. And then at line 3, we tell it where Redis actually lives. So in this example, it's on my local machine at port 6379 with a password. And from there, we can basically just approximately call functions that match up to Redis commands. So where you saw me type set my key or set my name Simon earlier, the set command in PyRedis looks like redis.set, name of the key, thing that you want to put there, and similarly get to get it back. So all of the data structures have different commands. When they return more than one value, you'll get a Python list, and in some cases you'll get a Python dict of name value pairs, for example, with a hash, but we'll again look at that later. So what happened when I submitted the form to start the draw was we hit this endpoint in the application, and we don't need to worry about how Flask works, but basically this code runs whenever that form gets submitted. and we get some values from the form. So it was submitted with a JSON array called prizes. And at line 9 there, I used the sadd command, or the set_add command that you saw me use in the command line, to add all of those to a key called prizes. I'm actually using a function called getKeyName there, and what that does is it puts prize draw app or prize draw colon in front of all the keys, so that all the keys for our application begin with prize draw, just so that we're being organized and using keys that another application sharing the database wouldn't overwrite, because let's say prize draw is a unique prefix. Once we've added everything to the set, we then see if I passed in a duration from the front end, which I did. I passed in an hour. And then we basically create a key at line 17 called isOpen, and we set that to be true. And that tells the application that there's a prize draw running at the minute. And then we set EX, or the expiry time, to be whatever the duration was. So in our case, we said it's going to run for an hour. And then we send all of those commands to Redis at line 19 by saying execute those pipelines of commands. And we just return OK. We don't care what the results of those are. They're all just sets. We're not interested in what came back. So if we look at the database view over here now, if I refresh this, we should have some keys. So these weren't here before. So when the application submitted this, it created this isOpen key, and that's a string. And we just put the value true in there. It doesn't really matter what we put in there, because we'll look at how this works in a minute, but our application is basically just going to check, does this key exist? And if this key exists, then we're going to let people enter the prize draw. When it stops existing, either because I delete it or Redis times it out and expires it, then the prize draw is over. So after an hour, if I come back to this or not, if I'm not watching it, Redis will delete this key because it has this time to live on it. So currently set to that long. I could override it here. I'm not going to, because I'm going to let the application do its thing. But there's nothing in the application is testing this. It's just whenever someone comes along and says, can I enter the prize draw? It'll check if this key's there in Redis. If it's gone, then no, you can't enter. And if it's still here, yes, you can. And Redis is managing that. And over here, we created some prizes. So I have my 4 t-shirts that I created. These are stored in a Redis set, so they have to have unique names, because if I added another Redis t-shirt, it would deduplicate it, and say you've already got that one. And the reason why we've put them in a set is we're going to use a behavior of sets to choose a random value later on. So the way we're going to allocate who wins is we're going to use a set command that randomly picks things. So at this point, we've got a prize draw is open, and we've got prizes. So what we then need to do is enter the draw. So if I go back to here, so you can now see that we've got all of the prizes listed out, and we've got a form that we didn't have before. So the front end's talked to the back end. It's asked, hey, is the drawer open? It said yes, and rendered out all of these prizes. And we'll look at how that works in a minute. I can then enter the drawer. So let's just switch back to so how did it do that? How did it stop displaying the empty page and know to display the page with the prizes on? There's essentially another Flask route for that home page, and when it runs, it checks a few things. So it calls this function here at line 2 that basically says, hey, if there's a key in Redis that exists called drawer open, and we don't care what the value is, we just care that it exists, then the drawer's open. So we are currently accepting new entries. And then we want to show the prizes to people. So the get prizes function down the bottom uses a command called redis.sMembers, which is set members. And we give that the key name prizes, so the set that we put all the prizes in. And what that does is it gets all the members of that set as a Python list. And then we send that back to the front end, and it renders them out. So that was how we knew it was open, was because these things existed in the database and what the prizes were. So this is the point at which, if you're interested in actually winning a t-shirt, and also if you're interested in helping me generate some data so that we have at least 4 users, because that would be kind of good, then if you can go to the URL there, so if you can go to win.simonprickett.dev, and you'll need a GitHub ID just because it's something unique that we could identify people by a little bit. And what it's going to do is it's just going to store your GitHub ID and get a little bit of information from your profile, which doesn't include email or anything that's not public. And we'll look at how all of that works in a minute. But if anybody wants to jump in and enter, then this is the URL, win.simonprickett.dev. I'll post it in the chat. And we'll look at how that works as well. So right now here in the front end, we have got this form that I can enter, and I can put in some GitHub IDs. So if I put in my ID, then great, I'm in the draw, and we'll see what that means in a minute. If I refresh the page and I put in another ID, great, the Octocat, the GitHub mascot, is also in the draw. If I try to enter again, because maybe I'm sneaky and I want to get a second, or I want to have more than one entry, really make sure I win this, then I get a message, oh, thanks, but you're already entered in the draw. So we'll see how that works and how it knows that too. And then if I come back here and I just type in something that's probably not a GitHub user, then it's going to reject us. So we don't have that GitHub user, they don't exist. So hopefully we got a few people entered. We will take a look at, but you can keep entering for the majority of the duration of this session. But there's no point trying twice because you only get one ticket if you like. So again, if you want to go there and enter, that's great. It's in the chat as well. So let's see what happens when I actually filled out that form and entered the draw. So there's a route in Flask for that, and it's basically it's basically receiving my GitHub ID from that form. So the first thing we do is we check, is the draw still open? Because between me looking at the form and then like going away, making a coffee or something and coming back, the draw might have ended because the hour that we gave it is up. So we again call the exists command in Redis and say, does that is open key really exist? And if it does, great, we carry on. Otherwise we bail out and say, no, it doesn't, it's not there anymore. Then we take the GitHub ID that you provided and call something called get GitHub profile that we'll look at in a minute to see if your GitHub profile exists and store some information from it if it does. If it doesn't exist, we return a 404 code, which is how the front end knew to say, oh, that one doesn't exist. If it does exist, we then, down there at line 16, we use the Redis sadd command. So again, the set add command, and we add your GitHub ID into a set called entrants. So people who are able to win the prize draw. We then look at the result of that at line 18, and what sadd returns is the number of members added to the set. So because we're adding one GitHub ID, the return value is going to be 1 if you weren't there already, or it's going to be 0 if you were there already and you're sneakily trying a second entry into the draw. So if it's 0, we actually return a bad request. So we say, no, you're not allowed to do that, which is how the front end then knew to display the message. Well, you're already entered, so don't worry about it. So you can't game this by entering multiple times unless you've got lots of GitHub IDs, and that's the logic that stops that. And if we did find your GitHub profile and you hadn't entered before, then we return basically a JSON object of some elements of your profile. So the front end could say, in my case, I think it said, thanks, Simon Prickett, because my real name is public on GitHub. So it was able to get that. And then looking at how it actually got the GitHub profile. So one of the reasons I use GitHub for this, this example is you don't need API tokens or a login or any setup or any craziness like that to get basic public user profiles. So what we do here down at line 8 is we get the URL for your user's profile JSON object from the GitHub ID that you provide us. And if GitHub returns as a 200, then great, we know that you exist. And then we store that profile in Redis so that when we need it again in the future as part of this application, either to check if we have seen you already or to tell you that you've won perhaps, then we don't have to go all the way out to GitHub and do that again. So what we're doing is we're storing that in Redis at line 14 using the set command, and then we're using the EX parameter at the end to basically say, I want to store that for 3,600 seconds or an hour. So how many times you hit the server or we need to get your GitHub profile in an hour, it's only going to make one trip to GitHub itself. The rest is going to be served directly from Redis. So this is important because like in a large application that does something with, I want to say a real API that has like tokens and stuff, you might have rate limiting and things like that. So you might not be able to hit the origin server every single time just in case. So you can cache some of this stuff in Redis for as long as you feel it's appropriate to keep it there, and then go back and fetch it again when it's expired. So assuming that we did go and fetch the profile and we stored it at line 14, if we then came back with my GitHub ID or one that we've seen before, what happens then at line 2 is we actually try and get it out of Redis first. So if we've already seen that GitHub ID and it's within an hour of the last time of us seeing it, we're not going to make a network call to GitHub or incur costs associated with their API if they charged us for that. We're going to get it from Redis because we know we've already seen it. And if we do that, we just shortcut out at lines 4 and 5 and say, we're done, we've got the profile, it's great. And if it's a new user or if it's one that's coming back much later, then we will go get it again. And this deleting these profiles kind of helps with memory management as well, because Redis keeps everything in memory for fast reads. So if we had lots and lots of GitHub profiles and we never deleted them, or most of these people won't win, we won't need that information again. It's kind of good to expire them after a while just to keep the Redis memory usage down a bit. So before we go on to ending the draw, we'll have a look at what the current state of Redis is. So we've added some users in here, or we've added some people who want to play the prize draw. So if we now look at what keys we've got more keys than we used to have, which is good because that means people have entered. So prize draw is open, still open. We're now down to 2,697 seconds, or however long that is. Redis is counting that down for us. And then we still have our prizes, and we now have this set of entrants. So, well, we did quite well. So we have 14 people here that have entered the prize draw. So they all got added to a set. So these are all people's GitHub IDs. Now, normally you probably shouldn't mess with a running application's data, but because we've got more people than prizes, I'm going to remove myself from this because I don't want to win. I'm going to remove Octocat from this because they're the GitHub mascot and not a real person. So we've now got the remaining 12 people in the set here that have the chance to win that. And then for each of those 12 people, we've created a key here. So if I pick on mine, so when we went to GitHub and we got the profile, we created a key called prize draw profiles and then the GitHub user ID. We said we'd store it for an hour, so it's counting it down. So 3,133 seconds, this will be deleted. And what you can see here is my GitHub public profile, which is what the GitHub API returned. And what we use that for is the front end used this name value, the name value, so it could see what my real name was rather than just my login, because those two things might not have any relationship to each other. And at some point, for people who win, we're going to use the avatar URL, and that's here as well. So this is all public information. There was no login required to get it. And it's all going to be blown away from Redis within an hour or faster if we close the drawer and delete things. So we now have all of these extra keys in here, but basically what we need to do is work out between two sets. So we have the set here of 13 people, and we have the set here of 4 prizes. So what we need is ideally a way of randomly choosing a prize and randomly choosing a person and associating them with each other, so we know who's won what prize. So we will go and look at how that works. So what I'm going to do is end the prize draw, and then we will see how we then produce this screen that shows winners with, where possible, their real name, the prize that they won, and their GitHub avatar, or the sort of fallback pixelated one that you get if you don't have a GitHub avatar. So we're not going to sit here and wait for an hour, or however long we've got left on that. So I'm going to go into here, and I'm going to end the prize draw. So I'll give this like 10 more seconds. If anyone else wants to enter, it's win.simonprickett.dev and your GitHub account. Because once we enter this, once we end this, you won't be able to enter anymore. Okay, so I'm going to end that. And now what we'll see is if we go to win.simonprickett.dev, the front end now says, oh, the draw's closed, but we don't know who's won yet because they haven't picked any winners. So when I ended this, what happened was it deleted that is open key that the front end uses to determine whether the draw's currently open for entry or not. So all of that stuff failed. And then the front end looked for another key that says, oh, do we have a set of winners or a data structure in Redis that describes the winners yet? And we don't yet. So the current state is the key for is the drawer open got deleted, but the key for who's won didn't yet get created. So what we'll do is take a look at creating that. So if I now click this, okay, so we've now drawn some winners. We don't know who they are yet because we haven't looked, but if you were to refresh the front end, it will now tell you who the winners are, but we'll take a quick look at how that works before we do it. So when we end the draw and pick the winners, what we need to do is, again, this is a Flask route that happens when you press the button. It does a post to a certain endpoint. And what we do with Redis, starting at line 7, is we basically say delete the is open key. So if the price draw hadn't timed out already, then delete it and close the draw, stop people entering. And deleting something that doesn't exist is fine as well. It's not going to cause an error. And then we have to work out who's won. So we create an empty Python dictionary at line 9 called winners. And then we go into a loop. And at line 12, what we do is we call, earlier I said there was like a behavior of Redis sets that we wanted to use for this. So the spop or setPop command removes an element or a number of elements from a set randomly. So it's great for this sort of thing. So we want to pull a prize out of the hat, and we want it not to be in the hat afterwards. So we actually want to remove it. We don't just want to pick a random item from the set and keep it in there. So we get that out. If we received one item out, then we've still got prizes to give away. So we start building up a data structure in Python for matching the prize to a winner. And then at line 20, we do exactly the same thing with that other set that had all of your GitHub profiles in. So we associate each of those 4 t-shirts with somebody, an entrant. And every time we're doing this, we're depleting those sets. So the next time we come around the loop, we can't pick somebody again that's already won something because they're out of the entrance set, and we can't pick a prize that we've already given to someone because it's out of the prizes set. So we do this until we're done, and we end up with a Python dictionary that matches prizes to winners. And then at line 31 down there, we use what's called a Redis hash that we'll look at in a minute that I said the very beginning models an object, so field value pairs. So a single key called winners in Redis, we're going to store the prizes will be the fields, and the GitHub IDs of the winner will be the winner. So we'll have Redis t-shirt winner, Redis t-shirt 2 winner, and so on. And then just for some good privacy reasons, we down the bottom at 34 delete the rest of the entrance set. So all of those GitHub IDs that we stored, we deleted. And obviously the profiles, we were using Redis as a cache for those, and we said we'd expire them after an hour. So those don't need explicitly deleting. They'll just disappear as we finish. So going back once again to the database here. So in here, we should now have, let's refresh the keys list again. We should now have some winners. So this is a Redis set. So as I said before, it's got fields and values. So these people here who have these GitHub IDs of won t-shirts. This is great, but not very useful for the front end. So we know that t-shirt 4 was run by this person, but we don't know enough to render a nice front end page about, hey, this person won and what's their potentially name and GitHub avatar, and the same for everybody else. So what we need to do is do something that works with this hash structure, so who's won, and all of these profiles that we stored before, to get some values out of the profile and build like a JSON object that the front end can understand, that has your name, what you won, and your avatar. So if we then actually have a look at the front end and see who won what nicely, so rather than in the database, we can go to here, and we should now see, so people have won. So in some cases, we had a mix of real names and avatars, or just the username and the GitHub default avatar. So we've done, this is good because we've done different paths through the GitHub profile. So congratulations to these people, you have won a t-shirt, and I will get in touch with you and figure out what size and shape you want. But let's see how we got there. So sort of pretty much the last bit of code we're going to look at is how do we get the winners? So there's again an endpoint in Flask that the front end says, hey, tell me who the winners are. And we're going to again cache this result in Redis, because calculating all of this takes a few commands. Commands take time. Redis is all about speed. So we know that the winners will be the same winners the next time somebody requests this document and so on. So we're going to build a JSON document and then cache it. So first thing we do at line 3 is we say, hey, Redis, get me the key winners JSON. And if it exists, great, we've already figured out who the winners are and built the nice JSON document for them. If it doesn't exist, we're the first person requesting this page, and we're going to have to build it. So at line 10, we use the hgetall, which is like a hash command for getting every field value pair. So all of the 4 t-shirts and all of the 4 GitHub IDs. And that comes back in a thing called winners. And we check that winners exist. So did we actually get anything from the database? And if it did, we start building up a list. And then we go through all of the prizes in the that we got back. So each t-shirt, and we look at the ID and the profile for that. And then at line 17, we call that get GitHub profile thing that gets us the actual GitHub profile. Now, these are all going to come out of Redis this time because everybody entered within an hour of us drawing the prize. So the profiles haven't expired yet. So that'll be super fast. It's all coming out of memory. We don't go hitting GitHub again, or imagine GitHub was your expensive API that costs money. We don't make any calls to that because we have all of that in Redis. It's remembered it for us. And then we just start looking at the profile and see what fields are set. So profile is your GitHub JSON document. If your real name was set, we use that as your winner name. And if it wasn't, we use your GitHub login, which is why you see a mixture of real names and logins. And then we use your avatar URL down at 27 for rendering an image for you. And we don't have to have logic there because GitHub always sets the default avatar. So if you don't have a photo or some other picture that you like, GitHub will set you one of those pixelated things. And then down at line 31, after we've done all of this work, which if there were like hundreds of prizes, might be hundreds and hundreds of Redis commands and a lot of network, then we cache it back in Redis again as winners JSON, so that the next time somebody comes to get that page, they go as far as line 3. We see, yeah, we've got a previously built JSON document. And then at line 7, we send it back to them without doing any work at all. So it's just come straight out of memory into the front end. So very fast. So that was kind of like a fairly brisk tour through some Redis concepts. So that the aim really is to think about using something that is a key value data store and which has different behaviors. So here we looked at like some of the behaviors of a mathematical set that you might not use in a normal database application, but there's other things like the list we looked at and streams and so forth. Redis is an extremely popular project. It's had over 1 billion downloads from Docker. It's probably in a lot of applications that you've worked on, whether you know it or not. Quite often it's hidden in caching frameworks or other infrastructure level things. It's a pretty interesting thing to play around with. And my day job is teaching people Redis online. So if you went to universityRedisLabs.com, we have 5 different courses. There's one for Java programming. There's one for Node that I teach. There's about to be one for Python. And then there's a couple that just teach you about the data structures and the product itself. They're all applicable to the open source product. They're all free. And you can get a certificate that counts as a credential you can add to LinkedIn by completing them. And at the minute, you can just go there, sign up, start immediately. And you have until, I think, the 31st of July to finish all of the coursework, but you can do it at your own pace. It's all online video-based stuff. And then if you're interested in the source for this application, so perhaps you're interested in how the front end works, or you want to see the entire Python Flask application, that's on GitHub, and I'll post this in the comments on Meetup and probably on Twitter as well. So that was all I had. So thanks very much, and congratulations to these folks here who I will find you through probably the Meetup comments, and we will send you t-shirts.
That's great. Thank you so much, Simon. This was super interesting, and congratulations to the winners. I tried, but obviously I didn't win, as always. But does anyone has any question?
Simon, how long does the coursework take?
I think we go about 3 hours a week to watch all the videos and do the coursework. So there's 2 sorts of courses. There's an introduction to Redis one that covers all the 10 data structures that were on my slide at the start with the key in the middle. That everything is multiple choice online questions, and there's like homework, which is at the end of every week, but we're currently running them self-paced. So a week is like a nominal thing. A week could be one evening, and then the next evening you do the next one. And there's 5 weeks of that, and then a final exam that's also multi-choice, and there's no time limit on it. You can like log off, come back a couple of days later, try it again. The programming courses for Python's not quite out yet. The programming courses for Node.js and Java that we have at the moment, they have an actual coding project where you build an application that does solar power energy monitoring, and it uses maps and Vue.js, and that's kind of cool, but you don't need to know Vue.js. Those are also assessed as multi-choice questions. There are programming challenges in the course, and we provide stock solutions and support on Discord, but you don't need to have done them to pass the course. It's like an optional, if you want to do it, that's great, and people do, but you can totally pass the course by just doing the multi-choice, because nothing in the programming is assessed. It's extremely hard to assess people's programming online with thousands of students. So basically we don't. And yeah, and everything applies to open source Redis. So obviously I work for Redis Labs. We're a company that we make open source Redis. We make commercial versions of it as well, if you want it hosted. But other providers also make that. And if you wanted to use another provider's Redis, then obviously our courses are equally applicable to their stuff.
Thank you.
Simon, when do you expect the Python version to be released?
We said summer this year. I want to say it'll be out by August. The way that we make these is it's a lot of face-to-camera videos, because we want to do actual presentations, and we use the light boards and things like that to draw out concepts. We obviously have a bit of a problem at the moment that we can't access our professional recording studio. So my colleague in Portland is currently recording it in his garage with a green screen. And we are doing a lot of post-edit stuff, but also like he has to stop because someone comes past with a leaf blower or something. So we're currently saying summer, but let's say maybe end of July. And the reason why is it's just difficult to produce like professional level content in this climate at the moment, and we're figuring it out. We've shipped a lot of equipment to a lot of people to do that.
Yeah, understandable. Thank you.